So thank you everyone for joining this session. Today we're going to talk about intent-based access control at scale with BPF and traffic pattern detection. So that was a teaser. I put BPF here, but as you can see, there's no E because it's going to be CBPF, but we're going to see some items on the roadmap. But the talk today is all about managing network policies, identity and access control for different types of workloads, serverless, within Kubernetes. So my name is Nick. I'm the head of developer relations at Otterize. So at Otterize, we build open source tools that make the life easier for developers, but also helping out platform teams and security teams. So just for my knowledge, who here is more of a developer? No dev? Oh, couple of you guys, okay. Platform admins? Okay. Security teams? A couple. So yeah, like developers are the minorities today, which is fine. Okay, so here this is Otis, the first Otter developer, and you can see he's looking pretty depressed because his company has asked him to apply zero trust principle to all his projects, the service is developing, the code is developing. And the problem is, as a dev, he accesses services all around the places. So he is accessing workloads in Kubernetes. Common workloads can be Prometheus, can be services owned by other teams or other colleagues. He's also accessing serverless services like DynamoDB in AWS, maybe some storage on Azure or Google. And the problem with that is if he's creating all those low-level policies to align with zero trust, so just a quick reminder, zero trust means that you're not supposed to allow access for any unauthorized calls or any unidentified. So basically, it's denial by default, except what is authenticated and authorized. And that's a problem, because in terms of cognitive load, as a dev, you don't want to learn all the security mechanism from every cloud for every single use cases. So typically, it should not be managed by developers. So who's the next one on the list? Well, it's the platform teams. But same thing with platform teams. The problem is as the code base evolve for the developers, you need to be aligned quite quickly in terms of the resources you need to access and how the policies, the security policies are deployed for those resources. So typically, you would open a Jira ticket maybe, or you will ask the DevOps admin or the DevOps engineer to adapt the Terraform scripts, whatever crossplane you're using on the IAM part, create new roles, new policies, etc. And this is really time consuming. And if you're, as a dev, in the middle of a sprint, you can't really afford to wait days to get this in staging and then in production. It takes a lot of time. And again, only developers know the communication patterns of their code and what services are accessed. Sometimes it's quite opaque for the platform teams, so we also need a mean to detect those patterns. Today, there's no out-of-the-box solution. Of course, if you've got Istio, it does solve some of the problems, but Istio itself adds a big layer of complexity at scale as well, without talking about sidecar containers and all these kind of things, right? So difficult to put in place and difficult to maintain. And of course, in terms of cognitive load, as I mentioned before, if you have to access services in a new cloud or a new way with new concepts, that's new skills for developers to learn, right? So typically, you want to offload this to the platform team. And then again, it's kind of a vicious circle where you kind of slowing down the productivity of developers, generally speaking. So how can we solve this? So basically here we have the different security domains that are disjoint. So there's Kubernetes Airbag, Cloud IAM, so it can be AWS IAM or whatever cloud, network policy, Istios, and then I didn't specify, but it can also be you need some credentials for database or access list for Kafka, when I say zero trust, you have to apply it across the OSI stack, right? From application to layer 4 to layer 7, layer 3, all that needs to be catered for. And so this is the idea of IBAC, intent-based access control, to provide you with a higher level abstraction that can automate the mechanisms that are specific to lower security domains. And because here we are focusing on network policies, this is just a small, as a developer, why network policies are not the right abstraction to begin with. If you think about it, network policy are namespace code. They are based on labels, and they are team dependent. So what that means is that at scale, you can't just apply labels per pod. You can just not rely on application labels. You have to group things together. And the problem with that is every team or even every developer may have a different naming conventions. And when times comes for a security audit, it's difficult, again, assuming no Istio, it's difficult to understand who's talking to whom. And from a network policy, tracing back the calls, because remember, network policy are applied on the server side, to understand which client are currently accessing my workloads and are matching specific policies within the network policy, it can be very difficult. Without saying that if you roll back on the server side, the server namespace, where you're putting all these rules, if you roll back to prior versions, you don't necessarily know which clients, which calling system are going to be impacted by reverting back on the server side, right? So it's very difficult to maintain network policy at scale using labels. And the risk is that everything will stop working the moment labels are not synced, right? So definitely as a dev, network policy is not the right abstraction. So IBAC, intent-based access control. What is this thing? So in a nutshell, it's a list of calls that you need to make. Very simple in the concept. So here a quick example where this is sort of application I've created to show you different principle in cloud native in terms of best practices, where it's a dad joke generator, but totally overkilled, where the idea is to get a dad joke from the OpenAI API chat completion from the users. You just ask the joke to an API endpoint. Is it working here? Do we have a... I'm not sure. No. So the joke service / joke here, this is the API that you call as a user. Then the joke server publishes the message on NATS, get picked up by the joke worker. The joke worker is then connecting to the OpenAI API to request the joke with chat completion, store it into DynamoDB, as well as in Redis, right? So typically what you need to call first from the joke worker perspective. So this is the microservice we're working on as a developer. So joke worker needs to call NATS, right? Needs to have access to NATS. So how can we do this? Using the client intent, which is the custom resource representing the IBAC concepts. And of course, we are leveraging the Kubernetes abilities to reconcile and do automation outside of the cluster to automate all the required workflow. So here, the example said NATS is another service running in Kubernetes, so Kubernetes workload. I just specify, from the joke worker, I want to call NATS. That's basically what I need. Then for Redis, same thing, running in Kubernetes, I just call the service name, Redis. Then I want to call OpenAI API. So here, the only thing is OpenAI API is on the internet. So we specify internet, the domain name that we need to access, and the type. And then we want to access an AWS resource. For that, we just specify the ARN of the resource. In that particular instance, it's a table, jokes table, and the permissions, like if you were doing it in a very simple manner, using AWS roles and permissions, right? So it's, from a Kubernetes perspective, it's automating the IRSA workflow, if you're familiar with IRSA and been through the pain of configuring IRSA in AWS. And that's about it. So if I do that, IBAC and our different operators, we're going to see how it works. But depending on the high-level policy, it's intelligent enough to automate all the required workflow behind it. So we've seen here it was for network policies and internet as well as AWS resources. And there's different things we can do with Otterize. So we work with 3 operators. Again, everything is open source. First, we have the credentials operator. So the job of the credential operator is to generate just-in-time credential for Kubernetes workloads. So it can be secrets like TLS certificates, username, password for databases, or cloud IAM credentials to access cloud resources. So in practice, what does that mean? It means that without Istio, we can very easily automate MTLS. So again, I meet with a lot of users who are using Istio solely for MTLS simplification, but it's just a small, portion of what Istio can do. But you still have the, overhead of managing Istio on top of that. So that can, if you just want to do MTLS, that can be a very good solution, just relying on that particular operator. For databases, so here I've mentioned DynamoDB, which is a serverless service, but you may be running databases as stateful sets within your Kubernetes cluster. So you can also manage username and auto-generate username and password and rotate the password without doing anything else but declaring the IBAC client intent. That's about it. And then Cloud IAM, every time we specify an ARN and then type the hyperscaler when you want to deploy the resource and the permissions, we're going to be using the Cloud IAM credentials as well and automate the workflow. So it can, so as I said, for MTLS, we can integrate with Spire, Spiffy, that's one way to do it, or we can integrate with Cert Manager as well. And our solution, you can, once you deploy all the operators, you can also connect to Otterize Cloud, where you will have better visibility and better reporting, which is also free of access, unless you want support. In that case, of course, you're going to pay for support. Then the second operator. So remember some of that, remember it, because at the end, there will be a quiz with some, I will make it a bit more competitive with interesting prices. So, and I'm giving clues there to be able to answer the quiz at the end. So be, careful with that. So second operator is the client intents operator. So the idea of that one is to reconcile the client intents with the lower security mechanism. So typically, I've mentioned already network policies. So when you call a service within Kubernetes, then we're going to translate this into network policies. Cloud IAM, right? Again, client intent will translate this into roles and permissions that are sitting in the target cloud. But we can do more, right? I mentioned layer 7. We can do Istio as well, right? So if you have Istio installed and enable Istio for a particular namespace, then instead of automating network policy, we will automate Istio authorization policy at layer 7. And then still, if you have more application running in Kubernetes, we can also automate Kafka ACLs and tie this to certificate as well. So we can go that far into the automation. And currently, we support also databases like PostgreSQL and MySQL. Again, everything is community-driven. So if there is a use case that you can think of that is not there yet, you can just maybe either do it yourself or just raise a PR on GitHub and say, OK, this is my use case, what you guys can do for us. And the last one, so the third operator, is the network mapper. So far, I've mentioned client intent, you do it manually. And this is where I think a lot of the magic happens. The network mapper is essentially monitoring DNS traffic as well as TCP sockets using CBPF, and is also monitoring API calls to things like AWS using IAM Live, so that we can detect what calls are made and calculate the required client intent to make your application work. So what that means is that essentially the client intents can be done automatically for you. Even if you don't know your application, if maybe there's some components you're not aware of, by using the network mapper, we will give you a clear map of what communication is happening in your cluster. With extra capabilities, such as if you have an existing client intent file that is somewhere sitting on a GitHub repository, we can also raise pull requests to change that particular file if we see that a new call is being made. So you will see the delta, and if it's a legit call, you can just merge the pull request and then use any GitOps workflow to apply that into your cluster. Or if it's something that is not intended, then you need to double check with the security guys what's happening in the cluster. And again, layer 3, layer 4, then layer 7, we can, if you have Istio installed, we can directly pull metrics from the Envoy proxy. So also detecting layer 7 traffic. So HTTP GET to what path into your container. So we can deploy, as I mentioned, IAM Live for API proxy. So when your application wants to access specific serverless part of AWS, we can detect the calls and place that into the client intent, like I've shown before, the particular ARN for a resource with particular permissions. We can also automatically generate the client intent for you. And then on the roadmap, because today we have IAM Live for AWS, but there are other clouds out there that don't necessarily have a open source project to act as a proxy and kind of snoop all those API calls. So for that particular use cases, eBPF, of course, will be the next step for us. OK, so now that will be the demo showing everything I've mentioned so far. So hopefully the demo gods are going to be with us. So maybe I should make this a bit bigger. Can everyone see that? Back of the room as well? Yeah? OK, cool. So here, I've got a Kubernetes cluster. It's basically running in GKE. So I've deployed Otterize here, so I can check in the namespace. Authorize system. So you can see the 3 different operators. So the credential, the intent, and the network mapper. The network mapper is, of course, the operator, and then you've got a daemon set, the sniffer installed on every node. Then in terms of CRDs, that is installed with Otterize. We have the client intent. Then for different services, we have other custom resources, like for Kafka, MySQL, PostgreSQL, and protected services. So protected services is a special one. Think about it for brownfield environment, where you can, when you install Otterize, there's 2 modes. Either you want to enforce, which means that we're going to create all those, translate and convert all those client intents into lower level configuration, or you can do it in shadow sort of mode, where we won't generate any security policies. We'll just, the client intel will be there. And once you've detected that everything is configured as intended, you can turn every service on by using a protected service custom resource. So it's more like brownfield environment. So those are the 5 custom resources you can use. So I've got an application running there, which is the classic. Let me show you quickly if I go back there. Yeah, this is the classic Docker. Can I present first here? Docker voting app. The only difference is that I've put a ingress controller in the front, and I've got the vote service, the result service, and then the vote is stored in Redis. The worker, I think, copies Redis to DB, and result is displayed also as a front end. And you can see here, there's a couple of network policy. That's 2, 4, 5, 6. Typically 7 network policy you want to create a zero trust environment for that particular service. So in terms of the namespace, I've got the voting app namespace here, the service deploy, DB, Redis, all of that. You can see that in terms of network policy, I've got 0 network policy currently. Client intent, I got 0 client intent. So now, first, to turn it into, so let's first check that it's actually working. So I've got the vote working, the result cube.local. Okay, so it's working. Let's apply first a deny policy there. Default deny, right? Okay, so in my network policy, I should see default deny, and then I should see the spinning wheel of death here, right? On the top, it's not working. Here, also not working with the here. Okay, so now I want to allow the different services to talk together, right? So for this, I can use the Otterize command line. So the first thing I can do is map out the application. So that's visualize. Oops, not this one. Authorize. Visualize. Where is it? This one. Network mapper. Visualize. Come on. Voting app and the default for the ingress app. Okay. Okay, so it's giving me a clear picture of my application currently, right? So I've got the ingress, I've got result, vote, etc. You can also notice this on Otterize Cloud, where you can here see that I'm assuming default deny, which is the case. Currently, vote cannot access Redis. Everything is red, is not authorized, right? So it's the same picture, but a bit more explicit. And you can see also the client intent I need to make it happen, right? You have all the recommendation, what is detected. So it's a bit more verbose than the command line. But with the command line now that have the visualize image, I can do also authorize network mapper, export. So export is going to generate the client intent. So you can see here all the client intent that I should apply to make the communication work, regardless of the lower level configuration. It just happened that in this case, it's going to be network policies. And then next step is just, that means I'm finished? No, got more. So the next step means that I can just use, oh, come on. Oh, come on, screen, okay. The next step is just to apply those network policies into my cluster. So voting app, kubectl apply, directly pipe it into it to apply this in the cluster. Let's monitor the client intent here. There were client intent, I should see new client intent, right? And as I see this, I should see network policy as well. So you can see I only had default deny before, and now I've got all those network policies that appears and that are managed by Otterize, including the labels. So now I have the right way to standardize all the network policy labels, but without managing all of that. I just use client intents in a very easy way. Actually, I didn't have to type anything. I just had to type basically one command line to manage the lifecycle of all the network policies. So now let's check that the application is working. And now it's working back, right? I can just dogs, cats, right? All right. Okay. So now, how much time do I have? Okay, so now it's time for the quiz. So that was it for the demo. So if you guys want to scan this, I'm going to start the quiz first. Let's host live. I'm going to put the, okay, start this one. Oh, no. I forget to do something. Oh yeah, this here. So what I'm going to do is going to ask you for your email so that I can get in touch with you later for the prize. If you don't want to participate and win the prize, put whatever email you want. And this is the game pin here. And you can go to, you can scan this or just go to this name here, domain name, kahoots.it, and enter this. All right. I'm going to just wait 1 minute. I mean, I started late a bit, right? So I have a couple of extra. Coffee break. Oh, that's fine, guy. Except if you really need some coffee, some caffeine juice. Okay. Let's wait a bit more. Come on, more. So in the meantime, yeah, just the price for today. The first price would be, so you will have a choice between either adopt an otter virtually, right? So that's for the WWF kind of charity. Either a charity voucher or Amazon voucher, whatever. We'll do it offline anyway. And for the second and third person, it would be like I'm going to send you a nice swag sort of pack with a lot of stuff directly to your home. So let's go back to where is the, here, Kahoot. Okay, let's start. So 6 questions. 20 seconds per questions, some multi-select, I'm going to tell you which one and how many answers. We're going to see if you're better than the Italians. Italians, maximum, some questions are really hard. So maximum they did was 67% for the winner. So you guys have to do better than 67%. Ready? Let's start. Germany versus Italy. Can be a good final for the Euro, right? Multi-select, 2 answer, correct. So that's first the question. With a service type load balancer exposed via an external IP, type load balancer, public IP, what are the most likely causes if the client IP, source IP, is not preserved when the packet reaches the Kubernetes cluster? External traffic policy is set to cluster, kube proxy is not functioning properly, the load balancer is misconfigured to use source NAT, a network policy is blocking traffic. I told you, this one is hard. Okay, so this one, so like 11 people for this. Okay, not too bad. So I'm telling you, explaining you why. Why external traffic policy is set to cluster is the right answer, and what load balancer. So if you think about it, when you expose a service as load balancer, you get a public IP. Typically, in a cloud provider, means that you are provisioning a load balancer in the cloud with a public IP. Now, external traffic policy, if it's set to cluster, which is the default settings, means that once the traffic goes to one node, it can happen that on that specific node, there is no pod belonging to that service that resides here. It's just like dumb round robin to whatever node from the load balancer. What happens in that case, imagine that, so if there is a pod there, that's fine. Nothing specific happened, the source IP is preserved. But if that node has to do an extra hop to reach another node where there's an actual pod that is part of that service, then it needs to do source NAT because of contract in IP tables, because of kube proxy, right? The traffic needs to be symmetric. So the destination node needs first to go back to the source node and then back to the client again. And the only way to reach back to the source node is to begin with to modify the source IP so that when you build the response, it goes back to the node, right? So that's one of them. And the second one, of course, if the load balancer has source NAT enabled, the client IP won't work. That was, I think, the toughest one. So next one. Okay, so who's winning for the moment? Okay, how to pronounce? Sternförmig Einhorn. I don't know what does that mean. But anyway, hopefully it's not something too crazy. Okay, second question. What is the default setting for external traffic policy? The answer was in the previous question. So if anyone does answer with the wrong one, man, that's... No! Who died? Of course, that was the right answer. Okay, anyway, so we still had some people do it wrong. Probably that was a misclick somewhere. So Sternförmig, Einhold still leading. Next one. When you apply a network policy with an ingress allowed rule, what is the default behavior for other traffic? So once you have allowed something in your namespace, from in the ingress rule, what the default behavior for all other traffic within that particular namespace or for the cluster. Allow all traffic for the entire namespace, allow traffic for the pod matching the policy, deny all traffic, or deny all traffic for the pod matching the policies. Okay, but this one should be easy, right? Once you are enabling a network policy, for a particular set of pod, of course, it's a default deny for the rest, right? It's as easy as that, but for that particular namespace, for the pod matching the policy. Okay, so 7, okay. Oh, this one is still leading. Oh, giving octopus is now the second. Next one. What is not an authorized custom resource definition? Protected services, client intents, Kafka server configs, Mongo server configs. Should be easier. I show it on purpose. Don't copy. Okay, yeah, of course. Still the same. Oh, yeah. Oh, it's getting closer with giving octopus. Also, the faster you answer, the more points you get, right? Almost on time. How many operators are used in Otterize by default? This one should be easy. I mentioned it several times. Don't count the daemon set, right? Just the operators. Okay, good. Closer. That's the last one. Multi-select, 2, right. What are supported targets for network policies? This one, a lot of people get it wrong. Services, labels, DNS names, IP blocks. What are supported targets for network policies? There's a trap. So, suspense. Okay, so services. You cannot use services in network policy because otherwise Otterize wouldn't need to exist in the first place, right? I mean, for network policies. So only labels and IP block. DNS names, I didn't mention it, but another feature that we have with a network mapper on top of BPF is what we call internet intent. And the network mapper can resolve DNS names in IP addresses. So what you can do is just rely on the network mapper to use DNS names and then translate this into IP addresses within your network policies. So typically, if you want to do that without Otterize, you have to use specific network policies like Cilium network policies or Calico network policies, because by default, DNS names are not supported. Just IP blocks and labels. Okay. So drum roll, third, what? So he lost the, no, that wasn't on, okay. Who is the winner? Okay, so giving octopus, that's great. So thank you guys. So now I will get in touch with all of you 1, 2nd, and 3rd, if you put your email address, and I will ship stuff to you guys. Okay, and just to conclude very quickly, a couple of more actions. Key takeaways: security is a team sport. Declarative access control, very important. And third one is empower developers. We want to, improve their productivity. Call to action. If you're interested into more details and do it yourself in your environment, we support many different use cases, as I mentioned today. You can scan this, get the tutorial. Tutorials are part of our test cycle, so it's for every new feature is going to work. Second one, if you want to also chat with me or with the dev team or with other community member, you can join the Slack channel here. And the last one, if you're curious about, I've mentioned external traffic policies, source NAT, destination NAT, and if you want to have a full picture on application with an ingress, a packet walk, I've written probably a 20 pages blog with TCP dumped and really getting deep into the different mechanism and traffic patterns into a cloud-native application. Just scan that. This is my blog post for that. And please, last one but not least, rate the talk so that I can improve it if you didn't like it, or if you like it, put it, a lot of love and a happy days with that. And that's basically it for me, guys. Any question? We're already too late. But if you have questions, we can just have a chat later, or do we have time for questions because it's coffee break?
Just go ahead.
Yeah, so if there's any questions, just ask, or we can chat later if you want.
Thank you. This is a wonderful, helpful technology. I just wanted to know, do you also support HTTP verbs?
HTTP verb, yeah. Using Istio, we will detect. So there's two things we support. We support with Istio, within the client intent, we support the verbs that you can use, and we also support that in the traffic detection. So there's one of the Netanel. If I do something, if I talk crap. We also support Linkerd. So he's my, corrector. So yeah, HTTP verbs are supported for Linkerd and Istio.
So paths and verbs are both supported?
Yeah, correct.
Okay, thank you.
Other question here?
I saw that you were generating... Thanks, Nick, for the presentation. I saw that you were generating a service graph in PNG format,
yep.
And the service graph was also exposed to Otterize Cloud. Do you have the ability to export that into a distributed trace?
Nathan.
Yeah, so this purely... This was the simple open source from our CLI graph. So it's actually the more predefined version. It's on our SaaS platform.
Yeah, and you can see that it's green now. Remember it was red at the beginning?
And that's allow you to get like meaningful and more action through our SaaS. But if you want to keep it open source and you just want to maintain the policy yourself and to view the graph very simply, I would say, so you can use the CLI, and that's nothing is sent to our backend.
Last question is, you generate automatically the different configuration for the network policies and all stuff like this. Is there a way to have a more like a GitHub approach where instead of applying it, you are pushing it to like a PR
so
request?
there's different. We have different users using different way to do it. As a dev, you can either collocate it with your code, which is the best way to be up to date, maybe in staging. In production, maybe you want the client intent to reside in a infrastructure as code repo. And then from there, once you have a validation from the platform admins, then you can use a GitOps workflow to apply those intents into the cluster when deploying into productions, right? So typically, for staging, you leave the developer just push their client intents, and maybe for production, you want to have like a more platform admin or security team validated workflow. What you can do as well is combine things. You can keep it this way, but use an admission controller like Kyverno. To have a higher level of policies or in terms of what developer teams can do what and where using Kyverno admission controllers for production. And actually, that's an item we're discussing on the roadmap, is how to implement validation workflow within the system. So it can be by having predefined templates for Kyverno, but today you would have it to do it manually with Kyverno. But we are thinking about putting this like in a more streamlined way into the platform. And the second part of the answer is also when you have a client intent in place and you do the GitHub or GitLab integration, then we can detect the delta and also create a pull request with the new client intent that can be validated or not, or merged or not by the platform team. We also have like chat ops, so we can also warn people on Slack if there is, like a new traffic pattern that is detected. So there's a multiple way to kind of answer that question. Any other question? No? All good? Thank you, guys.